Okay, good afternoon. Welcome, everybody. My name is Alex Pine. I'm with the Intelligent Infrastructure Cluster here at CITRIS, and it's my pleasure today to introduce the seminar, the second in the series. As you know, the series is organized by our Intelligent Infrastructure Cluster, and the goal really of the series is to present different theoretical as well as technological approaches to the broad topic of intelligent infrastructure. I think we had a wonderful lecture last week with Harry Korvitz. This week we're going to hear a lot about different topics, in particular participatory sensing, sensor networks, embedded systems, and in fact we're very fortunate with this week's speaker to have a lot of experience in various application fields which include earthquakes, traffic, health, and environmental engineering. So it's my pleasure today to introduce our speaker, Professor Deborah Estrin from UCLA, who has a PhD from MIT, and prior to this, who was at Berkeley for her Bachelor in Electrical Engineering. She is currently at UCLA, the John Postel Chaired Professor in Computer Networks, and also the founding director of CENS, the Center for Embedded Network Systems. So please join me in welcoming Deborah for this talk.
Thank you. I'm actually only going to talk about participatory sensing and none of the other things we've done at CENS. Marty, good to see you. In part, I think I was here about a year and a half ago and gave a little bit more of a background talk on other things we've done at CENS. And also, this is what I like to talk about these days, so that's what you get. We call this general, to try to tie things together, we refer to this general type of system as participatory sensing. It's a little bit of a misuse of the term sensing in many respects because a lot of it, as you'll see, involves a fair amount of human in the loop and is not completely automated, so take that term rather broadly. But really, after having worked in embedded sensing systems, particularly trying to build embedded sensing systems to support various scientific applications like seismologists, environmental engineers, terrestrial ecologists, and so forth, I became very intrigued by the existing base of, if you will, wireless sensors that are out there in the world, particularly mobile phones. And to some extent, we've looked at using those mobile phones for some of what we think of as sort of our legacy applications, but even more so looking at them for where they're useful in as much as they can capture information from and about individuals. And so really the overarching theme is that what can we do with this real-time instrument? It's more or less always on, more or less always carried, therefore it's not just the kind of information you can get from people when they're back at their laptop or when they're sitting in front of a web browser. It's always carried with them, and yet it's connected to the internet, so you have with you all the context, as I think of the cloud or the web, providing to that data. So it's really, the mobile phone is that important capture device that's carried, it's an important interface device, but really it's the fact that it's connected to the cloud, and there's all the historical, the models, the environmental data, spatial data, maps, and so forth that really brings that power here. A quote I often, a tagline I often quote is one of a little company that I found on the web, and their tagline is the power of the internet, the reach of the phone. And that's really what makes this technology base so powerful. And for us, we've really been exploring it by building different prototype applications, and from there sort of identifying where the technology challenges are. That's a little bit the inverse of how most computer science research is done, but since I'm not giving a computer science seminar for once, I don't have to worry so much about the fact that the talk is backwards for computer scientists for the most part. Computer scientists, for the most part, you talk about the challenging PhD topics that you have to do, and the applications you might build once you did those. And and generally, the way we go about this stuff is the inverse of that. So I want to talk about three sort of classes of applications that we've been iteratively exploring, prototyping, and developing for. Two of them fit into what I think you guys sort of call intelligent infrastructure, maybe only one of them, the middle one. But I'm going to tell you about all three because I think they're part of this sort of bigger class of ways in which, if you think about cities and urban structures and things as infrastructure, the ways in which we can use these devices. So And I ordered them sort of in order of technological simplicity or ease of implementation. So the first of these is the most mundane way in which people use smartphones, which is really, if you just think about that first killer app for smartphones, which were geotagged images. And we all take pictures on our smartphones and upload them to Flickr or wherever photo sharing website. And really, this application domain, which generally referred to as sort of civic and citizen data campaigns, if you will, is just doing that sort of with a purpose. So if you're trying to do some systematic data capture of a particular thing, then you can do what you can think of as crowdsourcing, or if you're not doing it out to an unknown crowd, but to a particular set of individuals who are motivated to collect this kind of data, it's an easy technology for doing that. So let me give you 3 examples. 2 are on this page, and they're all the same thing. One of these is just an app that was called Garbage Watch. We did it about a year ago for a group of sustainability students on campus who wanted to document where the campus should place more recycling bins. So a little application is something that it's a piece that runs on the phone and a piece that runs on the server. And all these apps are sort of mobile to cloud in that way. And it's just while they're walking around walking across campus, they see a garbage bin, they take a downward-facing image of the contents of the garbage can, and they tag it as containing recyclable items or not. It's automatically timestamped, geo-coded, and actually goes up to Flickr, and the website portion of it pulls the data from Flickr and puts it on a map, sticks the stuff in a database. Completely trivial, simple application to build. And a couple of things there, just for people, non-computer scientists in the audience. The state of computer vision is such that is not yet at the point that if you take a picture of a garbage can, that computer vision will automatically tell you whether the garbage can has recyclables or not. So no problem. You just tag it as containing a recyclable or not. We're not afraid of the human-in-the-loop component. So in all the systems we build, I'm interested in building things that current technology can support, and using that to actually build useful applications first, and secondarily, it also gives you some nice challenges for the things that the computer science can't yet do. So they went around over the course of a few weeks, gathered many thousands of images, did an analysis, wrote a report to the to facilities about where more where more recycling bins should be placed. It was an opportunity to talk about bias, right? So when you know that you're out there trying to capture information about where you have recyclable items, you tend to take pictures of garbage cans where there are more recycled items. Lots of interesting opportunities in there of things to start to look at and discuss with undergraduate students, but also the kind of thing that you would never spend a lot of money doing. So in some ways, the whole point of it is that the marginal cost of doing any kind of systematic data collection is virtually zero. So we were tired of looking at all these hideous pictures of garbage cans, and so sort of almost as a joke, one of the students on this came home from spring break, actually. His father happens to be a plant ecologist in Tennessee or something. So for his father, he had built the What's Blooming application instead, and just had a little app running where students around campus were taking pictures of flowers as they started to bloom. The most successful sort of used version of this thing so far, though, has been this example application, which is What's Invasive. So every natural area has invasive plant species. It has many invasive plant species that there's nothing you can do about them. You'd have to kill the local flora in order to get rid of the invasive ones. But there's always like a top 10 list of invasive plant species that you're still trying to eradicate so that you can protect the local ecosystem. Particularly important in the context of climate change, drought, and other variables to which, other phenomenon to which the local flora can be more sensitive than the invasives. And so we gave 10 phones with this app to the local employees of the National Park Service in Santa Monica Mountains. And over the course of 10 days, again, same thing. It just has the list of the top 10 invasive species, and when they see one, they can either tag it with a photo if they want to spend time, or without a photo. It's automatically timestamped, geo-coded up to a database. And so within the space of 10 days, they generated more data than they'd spent, 12 months generating previously by hiring somebody to go and do an invasive species survey. The important thing about that is that to some extent, what they generated before was not valid, useful data to them, because by the time they posted and analyzed that data, it was out of date, because this is a dynamic process. So most mundane of possible applications, you can now, if you're a wild natural area any place in the world, you can go and upload your top 10 invasive species list, and then somebody who's in your area, when they run this application, will get the top 10 invasive species for where they are, and they can contribute locally. I think it's mostly interesting from the perspective of how to support all kinds of employees who go around public spaces, whether it be National Park Service, people who work for the Department of Water and Power, people who work with facilities, as a very easy tool for documenting things sort of in the ambient environment. And just an example of all very, very mundane technology, but bringing the cost of that, bringing the marginal cost of doing that kind of examination very low. And so interesting to think how it can be used in changing the way both employees take on responsibilities, whether they're responsible for the city or the mountains for that perspective, but as well as individual citizens, and a very interesting tool for STEM education as well. So basic technology systems, all very much there. There are some interesting research challenges as you start to build these systems and think about scaling them. And in general, in my 3 example applications, I'll sort of throw up some of these and talk about one of them. And in this one, just to mention this whole, if you're really going to run this kind of a data campaign and this kind of a systematic crowdsourcing, if you will, getting that done isn't just as trivial as putting up an iPhone app and then hoping people will submit data. And so if you actually wanted to run a data campaign, you have to do it more the way that organizers and activists run campaigns, right? They try to get a community organized, get them doing things on weekends or on the way home from work. They see what kind of data they have coming in. And so the whole idea of actually building in the kinds of recruitment and even some of the reputation tools that we have from existing web and crowdsourcing-like applications certainly play in here. So we've done a little bit of building this kind of a campaign management engine to let people who want to run those campaigns identify user profiles according to their mobility and get additional data collected from people who are most likely to collect that data and so forth. And so you get into little sub-problems of how do you actually model people in a way that lends itself to predicting that they would be a good candidate for collecting more data for you in terms of their availability and all the usual problems of profiling them and aging that profiling and relearning and so forth. So nothing too surprising there, but I do think that we were having some discussions earlier that if you want to do some kind of crowdsourcing for a particular purpose, you're going to need to manage that process in some way, and you want data coming back from your systems. Fortunately, this is a really easy technology that, since it's always giving you back real-time information, that's a part of how it does its work. It's really easy to get a continuous pulse on what's coming back from your system and how good your data is, and to be constantly adapting your experiment to get the data you need. Okay, that was example 1 in the sort of class of the easiest way in which we can use these systems. And again, I mentioned it along the way, but the ways in which this can be used as part of high school classes, Girl Scout troops visiting the National Park Service, all sorts of youth activities around science, technology education, math education. It's an interesting, very available sort of, I think, complement, if you will, to robotics as one way in which you think about getting kids engaged in scientific and technical innovation. This technology clearly has appeal as well, and that's something we're doing some piloting of with LAUSD, the LA school system. Okay, so the second sort of ways in which we're leveraging these mobile phones, it's actually how I got to know Alex originally, is through a system that we built called called PEER, Personal Environmental Impact Report. And most of the work in this was done really a year ago, and we demoed it at Wired's Next Fest just about a year ago. And the whole idea behind it actually came from the fact that I had gone to talk to some people in environmental health, thinking, okay, we have mobile phones, maybe we can have air quality sensors, we can connect to them, and we can start to look at some things. It's another major issue, certainly, that LA is famous for many social problems, as all of my classmates told me when I landed here at the ripe old age of 17. In fact, sorry, anecdote number one, just because Marty's sitting there and it reminded me of it. When I got here, and I was a freshman, and I complained to Marty that whenever I went to the library, I couldn't find Marty Graham, sitting here, Marty Graham. I complained that I couldn't find books in the library. Whereas at UCLA, because I'd taken some classes there while I was in high school, you know, you could always find books. What do you think his reply was? It's because at UCLA, the students aren't smart enough to care about stealing the books. So, one of many chauvinistic comments about Los Angeles that I heard while here. Okay, back on topic. So, LA has proven to be a great sort of testing ground for looking at environmental and social issues because it's such a non-designed place. And so one of the questions was, I went and talked with an environmental health colleague about what about getting personal scale air quality sensors. And the short of that was that this is a fantastic research problem for people doing sensor development, but certainly in the time scale in which I was working then, and it's still the case, the availability of very inexpensive sensors that are going to measure things at the sensitivity that are relevant to human health, still not readily available. And so that was sort of in my mind. And in another context, a project I'm not going to bother speaking about, we were doing some work on using automated image capture off of an outward-facing phone that you were wearing for doing dietary health assessment and dietary assessments. And so I was driving around, walking around, going around with this phone hanging around my neck, taking pictures every 10 seconds. And for the same reason that I'm not talking about that project, I sort of became very disillusioned with the whole concept of wearing outward-facing cameras. And really two aspects of it. One is that my time series personally was really just two things: my laptop and my steering wheel. And so because I live in LA and I live far away and I have this very long commute, I don't spend a lot of time sitting down and having meals. And I do spend a lot of time in front of my laptop, even if I am sitting down and having a meal. So the two important parts about that is, one is that the quality of the images, even then, was such that you could read my email from these outward-facing images that I thought, as long as I remembered to take it off in private settings, it was fine, except it happened that you could read my email. So I was very much had that visceral sense of the privacy issues associated with this outward-facing cameras, and I've never quite been able to come up with a scenario in which I saw them since then as being really broadly applicable. But the positive side of it is I looked at these constant images of my steering wheel and decided, well, those images were clearly dull, but the time series of my GPS was interesting. And that from that time series of my GPS, there's lots of other information in there. So we started looking at how do you leverage, as Mobile Millennium and as Waze and many other applications also do, what can I leverage from what you can turn into an activity, time, location recording of an individual's life patterns at the scale of the individual. It's a pretty rich source of information with virtually zero effort on the part of the individual. So in capturing then, and as the phones became better, right? So we started this while the GPS was still outside the phone. It was a Bluetooth connected GPS, and then the Bluetooth, and then the GPS was embedded in the phone, and now we have accelerometers as well in our phone. And so it's a local running application that's recording your GPS and your accelerometer reading, and doing either onboard activity classification, as in more or less sedentary, walking, running, driving on highway, driving on surface streets. Some of which you can do on the phone itself, and some of which you need to do in the context of information that you either get from the web or you do it on the web, such as are you driving on a surface street or on a highway. So making use of an application running on your phone combined with data available on the web to capture that time, activity, location trace. And in the context of peer, we explored looking at both environmental impact as well as environmental exposure. So you take that time series, which is very personal to you, and you use that as an index into models that are available about the urban environment in which you live. So we weren't trying to capture original data. We weren't trying to capture data around traffic, which is what Mobile Millennium does. In fact, we were just trying to do something that said, if only one person runs this application, can it be useful to that one person when they run it? Can we do an application that doesn't require on achieving a density of deployment in a particular city? Because that will give us a set of applications that we can iterate with more easily. And I didn't have the creative thought or the guts to think about, you know, renting fleets of rental cars and actually getting the density you need to collect data. So the idea was, what applications can you build that just by capturing your location activity time series can start to give you information by leveraging what's on the web? So we're not collecting data in order to contribute to understanding something about the city. Most of these applications are about capturing personal data in order to reference information about the city to tell an individual something back that's useful to them. So I should have mentioned that before, that these applications that are about personal monitoring are really for personal applications. Now, eventually, that aggregate function is all very exciting and will undoubtedly happen. But these applications are ones that we knew how to sort of iteratively explore because they don't require that you get to a certain density in order to have value and return on investment. Okay, so this is the easy side for the most part. Programming the phones to do this data capture, there's one challenge, largely has to do with your battery. I forgot to ask you guys this question. Back here. This is my favorite location trace. It's getting a little old. I'll have to do something else interesting soon. Anyone know where that is? Nobody reads Japanese? It's Mount Fuji. So when the first week in July, I was traveling in the Far East, and we were had a vacation in Japan, and we climbed Mount Fuji. So that's the location trace of Mount Fuji as captured by Pier. What's that straight line down? Is there a cable car down from Mount Fuji? There's a hint because I took this, I went off on this tangent at a particular point when I was talking about batteries. So my battery ran out. Fortunately, at the top, it didn't pick up my trace until down there. So the one remaining challenge about doing anything on the device is still about doing it intelligently enough that you actually can last for a good 20-hour period until you expect that somebody would plug their phone in again. And so there's still a lot of room for fun exploration of algorithms to do more adaptive and intelligent sampling of the devices on the phone itself. But for the most part, most of the complexity in these applications has to do with the server side. So you take this activity location trace, and then you have these models that the city, the Air Resources Board, transportation authorities run of things such as PM 2.5 concentration. So the particulate matter that's one of the more harmful elements in particularly coming from diesel trucks. One of the most harmful components is PM 2.5, and people in your field, if you guys are mostly environmental engineers, as well as in public health, have developed elaborate models for taking select numbers of measurements, because they're big instruments around most urban regions, combining those with climate models, climate measurements, traffic models, and traffic measurements to come up with estimates of really what is an exposure map of PM 2.5 that is both spatially and temporally variable, but not too fine resolution. And the whole idea is then you take my location time series and you run that against that model, and then you get an estimate of my exposure to PM 2.5. So the idea here is, can we take activity time location series that are very personal to me, and through that come up with a personal model of my exposure? Similarly, for impact, can we take a carbon impact model, given the kind of car I have, and actually climate is an input to that as well? Can we have a model for my emissions based on my vehicle type, and then look at that across my time series, because how fast am I going and such are all parameters that I'm now measuring, and get a more accurate notion of my emissions? And we played with other ideas, such as your exposure to fast food. Not from the perspective of seeing did you walk into McDonald's, but what is considered by some urban planners and such the relevant information of how much time do you spend around areas, not driving by on the freeway, but resident in areas that are dominated by fast food establishments. And there are standard measures of a density of fast food establishments. And so you can look at different people's, again, take my personal trace through the week and look at my exposure and compare that across social groups. So that's what Peer does. It's a running system, and it was a really good exploration for us to identify where the hard problems were. And I was telling Alex before, we thought that what we were doing would be that it would be a relatively trivial problem to take this activity time location series and index into these running online GIS models that people have, and that whole server pipeline turns out to be much more difficult than we'd anticipated. One of the things we did in Peer from the beginning was look at that notion of privacy and say that while outward-facing images, my GPS time series is not as privacy problematic at face value as these outward-facing images. On the other hand, it's far more easy to process my GPS time series. And when you put my GPS time series up against maps, it's a very, if you will, telling trace. And that's what makes it so useful. And it should be an incredible tool for behavioral modelers and economists and social scientists of all ilks and health behavior and public health and all of that. On the other hand, from a privacy component, it's the easiest and most mineable data from which to infer very private things, that continuous time location series. So for Peer, we designed it that your raw data, such as that trace I showed you up Mount Fuji, is available to me, and what you share with friends or in some kind of a social networking peer kind of, peer in the other sense of the word, kind of competition is just the outputs of those measures. And in general, we've continued to explore this notion of building systems where your raw data stays private to you, and what you share then are the extracted features of that data. So you run the application to pull out of it your carbon emissions relative to how you did last week, or your carbon emissions relative to a friend of yours, and that's what you share, not your raw location time series. And in fact, it's in the Bay Area that we, there were a number of high school classes through Nokia. They got to know us, and they ran Peer to support a Go Green trial last spring, and they're planning to do it again. I think in the winter. So instead of keeping diaries of trying to change their transportation behaviors, they tried to have as a class competition which class could reduce how much they hopped into their private vehicles and increase their use of public transportation and just walking and cars and such. And instead of using individual diaries, they run Peer on their phones. They designed this, their own little Facebook widget, and it's been a fun engagement. Another follow-on application to that, which is much newer, is sort of a combination of that original thing I was telling you about of collecting geo-coded images for some data campaign, sort of data capture with an intentional purpose, and what you saw in Peer. And here we've been working with a small group of very avid bicycle commuters in Los Angeles. They're not, Los Angeles is a really interesting place to think about this because it's a city so not built for bicycle riding. These are not weekend bicyclists who are sort of going up and down the coast. These are people who, in the face of rising gas prices and a lot more attention to issues around climate change and so forth, we're trying to get more people to bicycle commute. And it's not just sort of shortest path or as the crow flies or as Google tells you to travel that really gives you the best route when it comes to cycling. So what they did is they basically ran a Peer-like application, accelerometer, GPS, continuously capturing when they would get on their bike. It's then uploaded automatically to the Biketastic map, excuse the name, student-determined name, democracy. And not only does it tell you sort of if you're traveling from here to there, which of these routes maybe are shortest from start and stop time, but it gives you some other possibly more interesting information, such as what's the quality of that route. So even if it takes me 5 minutes longer to take a different route, if I'm actually moving continuously on that route, instead of moving and then coming to a standstill and moving and coming to a standstill, I'd much prefer the continuously moving route for a couple of reasons. That stopping is probably at large intersections, particularly something more than just a very short stop at something like a stop sign, which means two things from a safety perspective. One is the exhaust, and the other one is the traffic, the level of traffic and traffic incidences. So just that automatic data capture we have a small community now who's starting to contribute to these maps and some interest from other cities as well. Some of the interest is from cities that are actually very navigable, and they just have so many avid bicyclists that they're interested in it. But this is really useful in a place that's not as navigable, because it lets you, in some sense, this is all about a sort of a mapping technology that lets you do very specialized mapping, something that's not important enough for Google Street Views to decide that everyone wants to see. It's not part of the generic base map. It's not even part of a layer, so you can create your own layers by leveraging mobile phones, whether it's those geo-coded images or whether it's these time series, which, depending what you're interested in, those are the features you pull out. And then sort of segueing over into health, which is the last application area I want to talk about before I talk more about privacy, is a project, one of our few international projects, Project Surya, run by Professor Ramanathan from UCSD, in which they're looking at, they're trying to do a very large-scale study replacing cooking stoves, traditional cooking stoves, with clean cooking stoves. Intended to have the threefold impact of reducing the health effects inside the particular home in which the cooking is being done, reducing the health impacts of those emissions in the village where all that cooking is done, because there's actually an outdoor air quality measured impact, and reducing the impact with respect to climate change, because there are these phenomena of these black clouds that contribute to warming. And so Ramanathan, who's an atmospheric scientist, has done some initial data collection and modeling of this process and has proposed this Project Surya to do a focused remediation. Okay, so what does that have to do with us? He wants to do an epidemiological study, so he's actually studying the change in health impacts for people living in the villages where he's doing this implementation, and he's going to use mobile phones to do that. So it comes in two ways. One is measuring that, getting that activity time location trace from the individuals where the clean cooking stove is being replaced, and ones where there aren't, control group sort of things. And it's just another context in which you want activity time location traces for individuals, so you actually have a more quantitative measure of their exposure than you get from straight self-report. And interestingly enough, they have a very simple filter that accumulates the emissions, the soot from these traditional cooking stoves, and they're sort of using the mobile phone to turn that sensor filter into a crude kind of sensor, because by having the people living in the home take a picture of that filter every day, you get a very crude sort of time series, and then they also document when they change it. And so this is in some sense about sort of, if you will, sort of a mundane or appropriate technology. And we'll see how it can be leveraged in this epidemiological study. As I sort of did when I talked about reputation and campaign management for those simple data campaigns, in the context of all these things that are making use of this automated activity location trace, again, for the most part, the basic technology systems are ready, which really means that the most important research to do with them, I think, is in their usage. So it's not so much for, a lot of it is not so much for computer scientists. It's for people who study, urban questions, behavioral questions, environmental engineers, traffic systems, epidemiologists, and so forth. To the extent that there are still challenges on the computer science side and the technology side, and where things still get a little hairy, they are in terms of this processing pipeline that you have to put in place on the server side in terms of being able to tap into all these different sources of data and modeling. And this is just a diagram of the processing pipeline that goes on behind Pier. And I would say also there's some nice little challenges in the context of even things as simple as location. So GPS coordinate is one thing, but in many contexts, when you want to sort of see where people are spending time, you care about these places, not so much about that GPS coordinate. And so you'll see there's still some challenge and opportunities for designing interesting algorithms to make our devices go from recording GPS coordinates to actually giving us a better sense at that abstraction of the places in which we reside and do those activities. Okay, so for the last sort of class of applications, which I started to get to with Project Surya, but much more generally and not so much in what you might think of as sort of more esoteric epidemiological studies, just think about this as a tool for helping people to understand or manage their health concerns. So instead of being put on some new medication or some new dosage of your medication, and then going into the doctor's office 2 weeks later to see how you're doing on that new medication, why not get more real-time and higher resolution information about how you're doing in response to that change in medication? So here's just sort of a rough diagram of the types of systems that we're putting in place, and they're really a combination of the previous two. There's automated time, location, activity monitoring, and there's that same kind of idea as take a picture of the invasive species, in the sense that you're doing a very simple human entry of data, but here that human entry of data is about yourself. So something that the social scientists refer to as ecological momentary assessments. It's something like if you will, a Twitter, right? It's what are you doing right now? How are you feeling right now? What is your blood pressure right now? What is your blood glucose right now if you're a diabetic? What did you just eat? And those very simple, human prompted, those are not things that we can automatically measure yet. Okay, yes, as the glucometers and the blood pressure cuffs become Bluetooth enabled, they'll automatically communicate that to the phone. But I think the point is that you don't need to wait for that. Everybody with a glucometer or blood pressure cuff can, first of all, be reminded to take that measurement, and then can enter that value. If you want to be sure that they actually are near their blood pressure cuff at the time, they can take a picture of their blood pressure cuff to sort of increase the incentives to not just enter what they entered the last time. And what you end up with then is this time series of those measures that you can combine with the automated measures such as activity, and you end up with a much more detailed, if you will, sort of living record of the individual's state. This is not something that you imagine people doing 365 days a year. This is what you go in and do at critical periods, when you're adjusting somebody's medication, when they're having certain problems, when they're just released from the hospital, when they've just had an outpatient surgical procedure, and you want to do more fine-grained observation of the wound, of their temperature. And I think, again, the point is that there are some things that are automated, and there are some things that are just very usefully done by prompting the individual to enter those values. And so out of it then, you get this, if you will, this living record, and you can think of many, many applications to which the same idea then applies. Somebody's needs to adjust their medications, whether it's a bipolar disorder, depression, anxiety, whole range of mental health disorders, even a clinical trial for any of those medications, where now the state of the art is that you do an adjustment, you do a treatment, the person comes in 2 weeks later, fills out a survey, answers a bunch of questions. And of course, the answering of those questions, you always have the bias of self-report. But self-report that's retrospective has a whole set of other problems associated with it as well. And so here you're getting an accumulation of in-the-moment self-report. You're not going to stop anybody from lying. I'm not trying to stop anybody from lying. But if somebody isn't intentionally lying, maybe you can help people to, in some sense, lie less to themselves. One of the interesting points about this is if you don't care about location, you can do this all just with a regular SMS-based phone. And one of our statistics grad students, you might want to check out this Your Flowing Data site. Anyone know him? He has this blog, and a lot of statistic nerds really like him. And to me, it's the only useful application of Twitter I've ever seen. Basically, his system follows you on Twitter. And so your flowing data follows you on Twitter, and you tweet whatever it is you're trying to monitor. And you can define what you're trying to monitor. So if you're trying to adjust how much Diet Coke you drink, and look at when you drink Diet Coke relative to what your sleep pattern was, you define the coding for following what you drink and following how you feel when you woke up in the morning. And you just do that tweeting. And on his site, he, of course, sticks it in a database and provides you with some visualizations to choose from to look at your trends over time. And just, I think, a really nice example of starting to sort of bring, if you will, statistics into people's everyday life. And of course, actually centered in Berkeley, there's been probably the source of that original movement of the sort of this, the examined self, and doing a lot of this more detailed monitoring and natural experiments on oneself. And I think this is a nice generalization of that idea. And in general, across these health applications that we've started to look at, whether it's chronic disease management or doing some kind of health behavior change or adherence observation on medications, and even starting to work with, in contexts where you have a community health worker supporting somebody in their chronic disease management. Or if you think about the elderly, it might not be the patient, if you will, him or herself that's doing this data entry. It might be the network of informal caregivers who are taking care of that individual that's tweeting on, what is the state of the person's general attitude, concentration, somebody who has some kind of dementia and so forth. That kind of situation is not monotonic. It's not constantly progressing. And so those sorts of community measurements that could then be used in an informal caregiving, context is interesting also because I think it's going to be in that context that we see more innovation than actually delivering data back to the doctors. So when you talk about this sort of thing to doctors, it's a problem, it's a liability, it's a lot of data for them to deal with, and in many contexts there's no real incentive to try to, in our broken healthcare system, which we all hear about way too much, it's very difficult to get these kinds of innovations. But I think if we focus on the individual in terms of self-care and community health workers and the family, you actually have a context in which you can get what are sort of affordable, approximate measures that can just be useful to people. You can start to, there's much more chance of seeing early uptake and innovation. So that brings me to, in this context, basic technology and systems are almost ready to use. But there are bigger research challenges, which is one of the reasons I am spending more of my time in this space than others. Clearly, lots of things in the HCI space and usability, data visualization. This is data that's at multiple time scales, smart and personalized triggering, feature extraction. What's interesting from an activity trace? If you're running peer, it's your CO2 footprint, perhaps. If you're studying people after they have hip surgery, it's, what's the diameter of their life, right? How much do they get out and walk around? Can they cross streets on time before the light turns red? If you're trying to encourage more physical activity in the morbidly, overweight, it's just how much do they walk. Right? If you're trying to look at somebody with progressing multiple sclerosis, you want to see some other features of their mobility patterns. So coming up with the right kind of feature extraction that is pretty flexible across different applications remains an interesting challenge. It's all, as many things are these days in computer science, all about machine learning. But the last thing I want to talk about, I already mentioned power consumption, is to come back to this question of privacy. So not so much in the first case of just taking geo-coded images, definitely in the context of tracing your constant path in the sense of peer, and even more so in the context of these health applications where you're not just looking at the data yourself, but you're sharing it with others. Privacy is a huge issue. This is a very granular source of data. It really quantifies our habits and our routines when it's combined with all the wealth of information that you have on the web in terms of maps, as I said. And it's of the reason that this will and is happening is because there's a lot there to be monetized. In terms of being able to take advantage of those patterns. And this is different than the data, to me, different from the data captured by your carrier, because carriers are regulated, and how and what they do with that data is also regulated. In this context, it's something you download, and you're free to make whatever choice you want. And we know, or some of us have opinions about, how good people are about making those choices. I mean, that the lure of the free application and the free service, one could argue, has not necessarily produced the best sort of public good when it comes to people thinking about their privacy. So the whole fact that this is something that individuals can do and then freely share in exchange for a small discount on a service, the fact that it is in control of the individual makes me more concerned about their privacy than when it's about a transit system, fast track, or the mobile carrier collecting the information. Because in this context, I'm freely giving it up to a completely unregulated entity. And so we've been looking at what might be, fighting a losing battle, but, the good fight, if you will, which is to introduce that there should be an alternative of a personal data vault. That raw information about yourself goes into a protected, it can be in the cloud, but an encrypted container in the cloud, not mineable by anybody, not run by somebody who also has an interest in the content of that data. And it's not a vault in that you never take anything out of it, but you actually then subscribe to third-party applications and decide filtered subsets of that information to go out, and in particular, extracted features from that data. So I don't want to just keep it on my phone for the same reason you don't keep your money in your mattress. It's not a robust, secure place to keep it. I'm not only interested in I don't want to just put it someplace and delete it continuously. Deletion isn't the answer, because if I'm looking at some health condition, I want to be able to compare how I'm doing now to how I was a year ago or 2 years ago, and what might have been some of those causes. So I want my raw personal data trace. I might want to pull different features out of it over time. But in some sense, I think of these data streams, the automatically captured ones, as well as those those diary pieces that I entered, my dizziness level while I'm on this medication, my fatigue level when I took that medication, the quality of my sleep the night before. Those things are pre-transaction. They're more private than the transactions I make on Amazon, right? You can argue, Amazon does argue, that the transactions I make with Amazon are shared information between both of us. It's not just my data. You could even argue that your electronic health record is already a somewhat public act, right? You got your blood drawn and tested and somebody saw it. This stuff is entirely personal. Nobody knows it but you until you're codifying it in this form. And so it seems worth thinking about what kind of combination of technical and institutional context can we get in to introduce a different notion of privacy here. And it really is a different support for privacy, and that, if you will, as computer scientists do, solve this problem with a level of indirection initially by having the data go into a personal data vault and then out to third-party services. And it's really a combined, a really classic socio-technical problem where there's work to be done here on the legal context as well as on the technical context. It's easy to do the initial trivial job of this. It's much harder to start to build a meaningful system that can import computations on your data and do so in such a way that everyday user who's busy doing other things in their lives can actually manage this sort of a system. That would be the time not to mention grandmothers. It's an inside joke. Okay, so just to wrap things up, across all these applications that I've described, there is an underlying architecture that we see, that we use, and that we think that as a community we can actually help to develop. And in part, some of my argument for doing this and trying to get other people to do this as well is that even if the early steps are not research, even more reason to develop an open interface architecture in which we as a community can be doing prototyping and collecting data and iterating and establishing privacy mechanisms that could then be incorporated into the larger running commercial and inevitably more closed systems. And so with that, I will end my formal remarks. Just I guess there's been one point of consistency over the last 5 or 6 years of the work we've been doing, which is a kind of this notion of making use of the sensors we have and figuring out the challenges, how to leverage those. And a second one of really taking on humans in the loop as a vital part of it and not being somehow afraid or dismissive of systems in which the humans are actually entering data, that there's still a lot of interesting capabilities from the fact that you can get data from people during the course of their day in a relatively systematic manner. And that we increasingly are trying to convince the funders that be, and even the commercial entities that be, that it was a really healthy thing for the world to have the internet, and the internet is a relatively open source of exploration. And in the same context here, it's good to keep these a certain amount of work going on in an open exploratory ecosystem where not everything is immediately monetizable. And that's all finish.
Well, Deborah, thank you very much for the very inspirational talk. We're going to give you this commemorative plaque. It's a tradition that goes back to the Nokia lectures on cyber-physical systems. So thank you very much, and if there's some time, we'll take some questions from the audience. So I'll fire off the first question. I think we saw at the very end of your talk several barriers to the explosion of these applications. I think we saw some very local success of a lot of them, and then there's the issue of bandwidth, there's the issue of battery, there's the issue of privacy, and there's probably even the issue of penetration of smartphones. And maybe the first question I have is, in your mind, how many of these barriers do need to fall so that we see the killer app that suddenly explodes over the earth?
So I guess in some sense I see, as ironic or perversive that sounds, that to some extent health is the killer app because...
that's really well put. Health is the killer app.
That health is the killer app because if you look at what's so special about this thing always being with me, right, what is most important to me? Yes, I think that there are certain sweet points, things like traffic, right, where you want to use me as a sensor. But if you move away from sort of me as a sensor, I see health as a big driver to that. And because it's a very low-cost option of trying to do things in a lower-cost way, things that were otherwise very difficult to do, a level of monitoring that you could only really think about doing if somebody was in a hospital or in a kind of a medical home situation. So I see health as being one of those apps, and I think it's intriguing to think about how can that start to emerge, because you can do it on non-smartphones as well as smartphones. In that example of that twittering to yourself, there are places to get started in that mode, even with regular phones. So I'm not good at crystal balling. I tend to think about. I think killer apps often come from things that can be done iteratively, and so I have trouble thinking about a killer app that we would design on some massive scale and then implement. Rather, those killer apps come about through things that people can iteratively go, and then suddenly there's a huge amount of interest in it, and people can self-adopt. But it's a non-answer because crystal ball is difficult.
Do we have any other questions?
So you bring up the medical application, but during your talk you were not too encouraging about it.
About health, yes.
Because you said the doctors were swamped with data. The last thing they need is more data.
I didn't say the last thing they need. The last thing they want.
Yes. On the other hand, I see that there are certain aspects of the data, like heart arrhythmias and things of that sort, that they don't even have any clue whether there's useful information in there.
Yeah.
And so what's it going to take to penetrate that? That represents 1/6 of the economy. If you can't impact 1/6 of the economy, that's... You
mean health?
Yeah.
Health is the killer app. There's a difference between, as Eric Dishman from Intel likes to talk about, there's the mainframe model of healthcare where you focus on the hospital and these acute disorders. And then there's the modern notion where you think about people out and about and where they spend most of their lives, which is at home and going about, and you think about prevention and you think about behavior change. And there I think that there's a real opportunity to get innovations introduced if they can be adopted by the consumer. So we will continue to work, and it will happen that and part it's the computer science, statisticians, whatever fault, that it has to be that this isn't overwhelming amount of data. You don't come, it's like the glucometers, the digital ones that you come in with these reams of, analog reads to the doctor. That is just a liability and not particularly useful unless you're a really nerd doctor and you're really interested in doing that time series analysis, right? And there are a few of those, but that's not the general case. And so we need to get the nature of those, the feature abstraction and the way we visualize those things so that it doesn't feel like overwhelming amounts of data. That will happen. I think it's well worth working on. I think that it will happen faster if we work in the context in which the adoption is much easier. We don't have all the problems with legal liability, which is in individuals, informal caregivers, even sort of HMO type nursing homes where somebody cares about trying to do a common sense approach to being able to do self-measurement in an affordable way. And that it'll eventually, of course, be done through in the more acute medical one, but that all just takes more time. There are much more resistance to sort of, oh, that's a good idea.
Thank you very much. Nice talk. My question is, let's see, couple or decoupling between, let's see, sensor block and the cell phone. As you mentioned, let's see, it's not easy to program the cell phone from the third-party guys. It's not easy to implement some specific...
We can hear you.
On the cell phone, it's not easy, and also it's belong to the carrier such as AT&T and Sprint. Some cases they don't like somebody else use that cell phone, very different purpose. So that maybe it's much better to a little bit decouple sensor side from the cell phone itself. Certainly, cell phone is useful, but some way we can use the wireless part of cell phone, for example, but mostly sensor block itself may be much more decoupled from the cell phone itself. How do you think about that?
So I think that the use of embedded, GSM communications, that you have a device that's using the cellular infrastructure. That's what you mean by decoupling it from the consumer purchased cell phone, right? Whether it's, you see that in the Kindle and other devices. That undoubtedly that will happen as well. So that is an interesting alternative, and an interesting non-alternative, an interesting thing that will happen in parallel. I'm particularly interested in the fact that this is what I and billions of other people care about carrying around, because this is what keeps me connected for a whole bunch of other reasons. And because it's what I intentionally carry around, I don't think it's either or. So I think that there's something to be leveraged because this is one device that I always want with me, and there are very large numbers of people who have it with them. And so there's an adoptability and an affordability, acceptability thing that I find extremely compelling. At the same time, clearly, starting to build those more specialized devices with embedded communication in them so that they're independent of these makes a lot of sense because it's cheap to do in any case. You have to then separately power them and those whole sets of other issues that I'm sure will all be solved in the longer term. I think that's an interesting path. It's just different from the one if we're talking about leveraging this large base, installed base of phones. And I don't find that some arbitrary artifact uninteresting. I find it extremely interesting that there are so many people who walk around with something in their pocket. And I can't do this sort of logical thing of, well, now let me assume that now that thing in their pocket is now this other thing. That will happen eventually. Which of those things will people have in mass? So if I was a hardware developer, I would definitely be looking in that direction of doing more miniaturized independent devices. I also think that eventually, this also might be naive, that it's a losing proposition for the carriers to really think, as the iPhone taught them, that they're going to control this device any more than, in the early days of networking, they ended up controlling the desktop or the laptop. So that just doesn't, in the long term, make any sense. And so being able to have individuals control their devices the same way they control their laptops is, the future or the current that I would design for.
So I'm referring to your project Surya. So how relevant do you think mobile phone as sensing platform is for developing regions? So if somebody cannot really afford an LPG stove, they really can't afford a smartphone to do sensing for them.
So this is not, there are many people who work, you have, it's not here, but you have Tapan Parekh here at the iSchool, and many people who have worked on mobile applications in developing regions. And for the most part, they found them to be tremendously applicable. So there are lots of things you can do that you don't need a smartphone, right? There are things that you can start off with doing in a mundane way that's just about time-stamped data. Any camera phone can do a fair amount of what's going on with at Project Surya. And in fact, in that one, they're using a Bluetooth temperature sensor so that they can actually see the elevated temperature as the measure for when they're in the huts, where actually cooking and exposed to that exposure. And that you can do with standard phones that are not smartphones, have Bluetooth and good. So I think that there's actually tremendous relevance because they're relatively inexpensive relative to lots of other instruments. But it varies a lot region by region, right? It's one thing in South Africa and another thing in India and such. And that's an epidemiological study. That's not a consumer action. So I think it's very difficult to give a general answer, and I wouldn't be the person to give the most credible one.
Okay, so we're at the end of the hour. I'm going to hand it over to